Okay, in class 27, number 1, we're talking about angles formed when we have two lines. Whether those lines are parallel or not doesn't really come into play yet, but those lines are cut by a transversal. So in the picture here, we have two lines. We'll call those lines M and N. And those two lines are being cut by this transversal. And when that happens, we have a lot of new angle pairs that have a name and then have special properties later on. So we're first just going to work on the names and the new vocabulary. So the first one is the word corresponding. So we have a pair of angles called corresponding when this happens. So I'm going to write that here, corresponding. And we're starting with that one because the word corresponding is familiar to us. We talked about corresponding angles when we were dealing with triangles. So when my two lines are intersected by a transversal, my corresponding angles are the ones that are in the same spot. So for my two lines, these green lines here that are being intersected by my transversal, I'm going to go underneath my green line, but to the left side of the transversal, this angle here. But then down here, it's that same angle underneath the green line and to the left of the transversal. So again, this is my transversal. I'll call it T. And these are my two lines being cut by the transversal. So in the picture, angle 1 would go with angle 3. So what angle up here in this group of 4 matches up with or corresponds to the angle down here in this group of 4? So angle 1 would go with, it's an and sign, angle 1 and angle 3 would go together as corresponding angles. Then if I went over here to angle 2, angle 2 would go with angle 4. Let's go down here to angle 5. Angle 5 would go with angle 7. And then angle 6 will go with angle 8. So that's our first type, corresponding angles. Okay. Our second type, we're going to stay with types that are on the same side of the transversal. So see how these two were both on the left side of the transversal? Well, our next type also are two angles that are on the same side of the transversal, but instead of being in the same spot, they are going to be consecutive, meaning in a row. So consecutive interior angles. Now we can't just say consecutive because that just means like back to back, okay, or in a row. So these two angles here, 1 and 2, those are consecutive. They would be back to back, but they're not interior. And the reason that we don't call them consecutive interior, they're not interior, but they also have a different name. Angles 1 and 2 would be a linear pair. So they already have their own name. 2 and 5 would be a linear pair. 5 and 4 are our consecutive interior angles. So if you look at the picture down here, again, we've got our two lines, M and N, being cut by our transversal T right here. Consecutive interior would be angles that are in order, in a row, on the inside. This is considered interior, in between our two lines M and N. Okay, up in the picture, That is our angles 4 and 5. So angle 4 would go with angle 5. And consecutive interior on the other side of the transversal would be angles 3 and 6. Okay, so what we have over here on the left-hand side of the paper are angles that are on the same side of the transversal. What if they're not on the same side? Okay, well, that's what we're going to have over here on this side. We're going to have angles that are on opposite sides of the transversal. Okay, so let's talk through those. The two that are on opposite sides of the transversal are alternate just meaning opposite side, alternate interior, and alternate exterior. So again, I've got my two lines, M and N, that are being cut by my transversal T. So two lines, M and N, being cut by this transversal T. So again, this is my interior. We just talked about that. So alternating means they have to be on opposite sides of the transversal. So highlighted in this picture is this angle here. And if I pick one that's on the left side of the transversal, the other angle would be on the right side of the transversal. So up in the picture, again, you can only pick angles that are on the interior right now, because I'm talking about alternate interior. So we would be talking about angles 6 and 4. Or my other pair, if I start on the other side, I would go angles 5 and 3. And the only difference when we head to the alternate exterior is they do have to still be on opposite sides, but this time they have to be outside of my two lines M and N. Okay, so if I pick an angle on the upper right-hand side, that's in the exterior, then I'm going to have to go outside of my two lines on the left. This would also be exterior. So in the picture up top here, my alternate exterior, if I started at angle 1, go all the way to the other side, angle 7. But if I started at angle 2 would go with angle 8. Okay, so that page, and again, you can pause or you can rewind and replay any of that you need to, but this page is really the most important because it's a reference guide for the names of the angles that we're going to be using throughout this entire standard. So make sure that you have those names somewhere written down so that you can go back and refer to them throughout the entire standard. Now we're going to practice, but we're going to practice in a way that our picture is a little bit more complicated, and so it makes it a little bit more difficult to determine interior and exterior and that kind of stuff. Okay, so pause if you need to so that you can finish writing down, or just continue on. Here we go, 14 and 16. We're going to go down to this picture at the bottom that's a little bit more complicated. And we're talking about angles 14 and 16. What kind of angles are those, and what is my transversal? Okay, so if I'm looking at 16 is here, 14 is here. So 16 is in this group of 4, 14 is in this group of 4. So I'm going to cover up the angle pairs or the angle groupings that we actually don't need. So I cover up these 4 and the 4 over on here on the right hand side because they're not really in this problem. Okay, so 14 and 16 are here and here. Those both touch line L, which is this line right here. So because that's the line that they have in common, that is your transversal. Line L is our transversal. Okay, so what kind of angles are they? The only reason we need to identify the transversal is so that we can say, are they on the same side of the transversal or are they on opposite sides? So if you're looking at the transversal here, 16 and 14 are both on the bottom side of the transversal, so they're on the same side. So your options are now corresponding or consecutive. This one is really easy for us to figure out because of the fact that the numbers are also consecutive. So 13, 14, 15, 16 are 14 and 16 back-to-back numbers. Nope, because 15 is in between them. So this is not consecutive, so it's corresponding. Okay, 7 and 12. 7 and 12. So I've got to find number 7. So here's 7, and here's 12. So these two groups of 4 are needed. These groups of 4 are not. So I cover them up with my sticky note so that I'm not worrying about them. Okay, my transversal. What line do they both have in common? Which line are they both touching? This one here, which is line M. Are they on the same side of line M? No, 7 is on the left, but 12 is on the right. So they're on opposite sides. So the question is, are they opposite interior or opposite exterior? And when we talk about interior, exterior, it's really important that you cover up all these extra angles and you're not looking at the whole picture. Because I just want to know, here's my 2 lines. Are they in between those 2 lines or are they on the outside of those 2 lines? And they're inside. So this is interior for my 2 lines, K and L. So 7 and 12 are alternate interior. Okay, right here, I would go ahead and pause the video if I were you, and I would see if I could do 1 or 2 or 3, the last 3 on my own, and then come back and unpause and see what the answers are. Letter C is 7 and 2. So there's 2, there's 7. So none of these angles have anything to do with my problem. The line they have in common is this line here, K. So K is my transversal. And again, don't look at anything else except for the 2 lines and the transversal involved in the problem. So my 2 lines here and here, 2 and 7 are on opposite sides of my transversal, and they're on the interior. So they are alternate interior as well. One and 8 are on this same grouping, so K is also the transversal for 1 and 8. They are not, again, they're on opposite sides of the transversal being the blue line here, and they go all the way across on the exterior and the exterior. So these ones are alternate exterior. And the last one's 8 and 12. Got a lot of colors going on here. So 8 and 12. Those are on the same side of my transversal. So my transversal is the one line that cuts the other 2. So they're both on the same side, the right side. So they're on the same side. So question is, are they consecutive or corresponding? So consecutive doesn't always have to be like 8, 9, 10, right? So 4, 8, 12, 13, are they back to back? Yes, there's no other angle in between them, so 8 and 12 are consecutive. So my transversal was line M. These are consecutive interior. Okay, and those are names. You're going to have to keep coming back to this piece of paper to see what the names are. You're not going to have those memorized overnight. So keep coming back to this piece of paper. Keep coming back to this top part where it has the names and it has a picture of them so you can see them. Okay, so the next 2 pages here are just justifications for the statements that I'm about to make. So anytime a geometry mathematician makes a statement or makes a claim, they should prove it. Especially in geometry, it's all about proof, justification for why you're able to say something. So the most important part of this box right here is this statement. Okay? Okay, I'm going to get to that statement in just a minute. First thing I'm going to do is I'm going to translate the points A, B, and C in the same direction. So when you translate, you move something by the same distance and in the same direction. So I'm going to move B by that much. I'm going to move A by that same amount. Bring it down here. So A prime, here's B prime. And then I'm going to move C down that same amount as well. So C is going to come down that same amount, C prime. So I just translated them all in the same direction by the same distance. Okay. If I draw a line through B prime and C prime, I just remade this same line down here, which means those 2 lines are parallel to each other. So this means I have made parallel lines. And you might be thinking, why is that important? Parallel lines are super important for us because now that these are parallel, I can make the following claim. Because I just did a translation, and translations are what's called a rigid motion, angle measures are preserved, meaning that when I took this angle ABC, this one right here, and I translated it down here to A prime, B prime, C prime, those 2 angles stayed the same. Those angle measures stayed the same. And because they stayed the same, that means these corresponding angles, those are corresponding, angles are equal to each other. But they're only equal because of the fact that I made parallel lines. Okay, so when lines are parallel, my corresponding angles are congruent to each other. And all of this down here was just my justification for why that statement I just made is true. It's not necessarily super important for you to be able to recreate that comment or that statement, but I'm justifying it to you why it's true, and that's why it's true. Okay, but now we know that, and so now we can use that as we move forward. Okay, so when we move forward to alternate interior angles, okay, I'm about to make a statement about alternate interior angles. So alternate interior angles are what when lines are parallel? Okay, we're going to figure that out here. Okay, so this is a parallel marking, just so we're clear. This marking here, this means parallel. Okay, so because my lines are parallel, I just said up above, any corresponding angles in the picture are equal to each other. So are there corresponding angles in the picture? Yes. My corresponding angles are angles 1 and 2. Why can I say that? Because they're corresponding. Ooh, my pen's running out. Because they're corresponding angles. Now, there's something else that we know, but we know it because of units 1, 2, and 3, not because of currently. In the picture, I also have a set of vertical angles over here. So I also know that those two angles are equal because they're vertical. Okay, now I'm going to introduce something right here in this proof, and it's okay if you don't remember it from this day forward, but we're going to use it again multiple times. So I want you to see it at least once, if not twice. So the next thing I'm going to write down is actually a statement from Algebra 1. So in Algebra 1, we learn that if A is equal to B, but B is the same thing as C, then aren't A and C also equal? And that's called the transitive property. And that's what we're going to do. We're going to do that same thing. If 1 and 2 are the same thing, let's say they're both 80 degrees. Let's just pretend. If this is 80 and this is 80, this is 80. I already said that. So that's 80 as well? Yes. And so what then we can say is that angles 2 and angles 3 are congruent by the transitive property. Okay, so what just happened? I just made a statement about alternate interior angles. Because if you look at the picture, angles 2 and 3 are alternate interior. And what did I say about them? They are congruent. So this is the most important part of this box, is that you know from now on that they are congruent to each other. So anytime we come across alternate interior angles, we can set them equal because they're congruent. So correspondings are congruent, alternate interiors are congruent. Are they all congruent? No, they are not. So let's go down to this bottom here, and again, same thing. The most important part of this entire box is right here. That's the important part. Okay, 1 and 2. Look at here, 1 and 2. Oh, we just saw that twice now. 1 and 2 are corresponding. Those are corresponding angles. So they are equal to each other. I think numbers are easier to deal with. So let's throw some numbers in there. Let's say that is 80 degrees. What about 3 and 2? 2 and 3 here. If this is 80, then the one right next to it, is that 80? No, but it is 100 because these are a linear pair, which means they add up to 180 degrees. So I'm going to write that in. That's 100. Okay, so looking at the picture that you have here, what is true about angles 1 and 3? What is true about 1 and 3? 1 and 3 add up to 180 degrees. So what is true about consecutive interior angles? These are consecutive interiors, 1 and 3. They don't equal each other, but they are, here's the word, here's the fancy word, supplementary. Sorry that I'm covering it up, but I had to write really small to get it to fit in that box. Supplementary. So consecutive interior angles are supplementary when my lines are parallel. Okay, last page. Okay, so this one is very similar, alternate exterior angles. So I'll run through this a little bit faster than we did on the last one. In the picture, again, angles 1 and 2 are corresponding. So I can say angle 1 is congruent to angle 2. Those are corresponding. But, okay, so 1 and 2 are corresponding. But then look here, 1 and 3 are vertical. Those are vertical. Okay, so then, if angles 1 and 2 are the same, but 1 and 3 are also the same, then that means 2 and 3 are the same by that transitive property. But if you look at the picture, what do we know about 2 and 3? 2 and 3 are our alternate exterior angles. So what did I just say about them? They are equal to each other. So they are congruent, equal to each other when we're talking about a number. Okay. So then, what we're going to do now is actually look at, I'm going to give you a number. You're going to figure out this other angle, and you're going to tell me what kind of angles they are. So if they are corresponding, they are equal. If they're alternate interior angles, they're equal. If they're alternate exterior angles, they're equal. The only time they're not equal is if they are consecutive. They are supplementary. Okay? So each problem is different. So angle 1, or the first problem, angle 7 is 100. So this first problem, angle 7 is 100, but the next problem, it's not 100. So they're not related to each other. So all you have to do is look at angles 7 and angles 3. What kind of angles are they? And then use that to figure out the measure. 7 and 3 are corresponding. So if those are corresponding angles, they would be the same measure, 100 degrees. Don't forget the degree measure because the Go formative will count it wrong if you don't put the degree measure on there. Number 2. So I just said that angle 7 was 100, but now it's not. So when you move to the next problem, that number 100 goes away and we restart over with a different angle measure. Okay, so angle 1 is 120. So here's angle 1. How does that relate to angle 7? Those are alternate exterior so they should be equal. So that would also be 120 degrees. Okay. This is another one. I would pause the video right here, try numbers 3 and 4 on your own, and then press play and continue. So number 3, if angle 3 is 140, 3 and 5 are alternate interior angles. So they would be equal. So that would also be 140 degrees. 3 and 6 are in order on the same side of the transversal. So those two would be consecutive interior, which means they add up to 180 degrees. So I'd have to subtract 125 from 180 to get 55. Okay. Then we just move into some other examples with a more complicated picture. So here's where I would bring my sticky note, or you can use your hand, bring my sticky note back into the problem. where I would cover up the angles that aren't involved in the problem. So here I'm dealing with 7 and 12. So 7 and 12, you might be able to tell, or you might not be able to tell. So I would cover up the angles that are not involved. And then maybe you can easier tell what kind of angles they are. So 7 and 12 are on alternate sides of the transversal on the inside. So they are alternate interior. So they are equal. So if 7 is 95, then 12 is 95. Okay, then I'm going to get rid of my sticky. Look at angles 1 and 9. So 1 is up here, 9 is down here. Let's cover up those angles this time. So 1 and 9. Those are in the same spot. 1 is on the upper left-hand side. 9 is on the upper left-hand side. So those are corresponding. So angle 9 will also be 125 degrees. Just really quickly on the last two. Again, you can pause the video and then push play to see if you can do 7 and 8 on your own. Number 7, angles 9 and 5 are consecutive interior. So I would take 180 and subtract the 140 to get 40. 3 and 13, I've got to go over here to this group this time, 3 and 13. They're exterior and on opposite sides, so that would be alternate exterior. So if angle 3 is 91, angle 13 would also be 91 degrees.